Chalo, let's tackle a super interesting topic today, parametric differentiation. So, in differentiation so far, we've always seen x and y directly linked, right? But what happens when they're not? Think about it like this. What if x and y are two people who don't even follow each other on Instagram? How on earth could there be a connection? Well, here's the twist. What if both of them follow the same famous influencer? This influencer, this celebrity, is their common link. Even though they don't know each other, they're connected through this third person. In our math world, we're going to call this influencer unknown. So this whole mutual friend or mutual influencer idea, that's exactly what a parametric form is in mathematics. It's just a fancy way of saying we're connecting x and y using a go-between, a third variable. And it looks like this. You see, x is defined as some function of t, and y is also defined as some function of t. They don't have a direct equation with each other, but they're both connected through our parameter, t. Okay, so the big question is, how in the world do we find dy dx if x and y aren't talking to each other directly? Now, there's a special formula for this. It's kind of like a secret tool. And I promise you, it looks way scarier than it actually is. It's super, super simple. So let's check out this secret tool, our parametric power-up formula. This is the key that unlocks all these problems. And here it is. That's it. To get dy dx, all you have to do is find the derivative of y with respect to t, then find the derivative of x with respect to t, and then you just divide the first result by the second one. It's that straightforward. All right, enough with the theory. Let's solve a real problem, step by step. You're about to see just how easy this whole thing is. So here's a classic question. You'll find this type in your NCRT textbook. We need to find dy by dx if x is equal to 2at squared and y is equal to a to the power of 4. We are going to use a simple 3-step master plan. Seriously, if you just remember these 3 steps, you can solve any parametric problem they throw at you in the exam. Okay, step 1. We find the derivative of the x equation with respect to t. Now 2a is just a constant, right? So we leave it alone. The derivative of t squared is just 2t. So we have 2a multiplied by 2t, which gives us 4at. See? Just your basic power rule. Now for step 2. We're going to do the exact same thing, but for y. We differentiate the y equation with respect to t. Again, a is just a constant, so we don't worry about it. The derivative of t to the power of 4 is 4t cubed. So our answer is 4at cubed. We're almost there. And now for the final and easiest step. Step 3. We just plug our 2 results into our power-up formula. So that's dy by dt on top and dx by dt on the bottom, which means we have 4at cubed divided by 4at. And now we just simplify. Look, the 4a on the top and the 4a on the bottom, they cancel each other out. Gone. Then the t at the bottom cancels with one of the t's from the t cubed on top. So what are we left with? Just t squared. That's our final answer. See? Simple, hey na? Okay, listen up. This is super, super important. Let's quickly go over some common mistakes, some exam traps that students often fall into so that you can avoid them and get full marks. So many students get confused here, but here's the trick. First, remember the formula is division. Don't accidentally multiply them. It's a common mistake. Second, always make sure the denominator, dx over dt, is not 0. And please, please, please double check your algebra when you're simplifying. Getting these small details right is the key to not losing easy marks. All right, let's do a quick fire 30-second recap, just to make sure this whole concept is locked into your brain for good. So always remember the master plan. Step 1, differentiate x with respect to t to get dx over dt. Step 2, differentiate y with respect to t to get dy over dt. And step 3, divide them. That's it. That is the entire topic right there in 3 simple steps. And there you have it. Excellent work. You've officially unlocked a new math superpower. Parametric differentiation is a really useful tool. Now, the next step is for you to grab your textbook, practice a few more problems using our 3-step plan, and you will absolutely be unstoppable in your exams.